Bridges are more than just structures, they are lifelines. They connect communities, economies, and people. Imagine a world without bridges. Transportation would be chaotic. We'd be stuck navigating treacherous waters and rugged terrain. Thankfully, bridges exist, and they come in all shapes and sizes. From the towering suspension bridges to the humble footbridges, each serves a unique purpose. Bridges are essential for transportation, facilitating the movement of goods and people. They are critical for trade, tourism, and everyday commutes. Without bridges, our world would be a much more difficult place to navigate. Building a bridge is a complex undertaking that requires meticulous planning. Engineers, architects, and construction workers collaborate to design and erect these marvels of engineering. The first step is site selection. Engineers analyze soil conditions, water levels, and seismic activity to determine the most suitable location. Once the site is chosen, the real work begins. Geotechnical surveys are conducted to assess the ground's stability. This information is crucial for designing the bridge's foundation, which must be strong enough to support its weight and withstand environmental factors. The foundation is arguably the most crucial part of a bridge. It provides the stability and support for the entire structure. The type of foundation depends on the bridge's size, design, and the ground conditions. For smaller bridges, spread footings or pile foundations might suffice. Larger bridges, however, require more robust foundations, such as caissons or deep-drilled shafts. These structures are sunk deep into the ground, sometimes hundreds of feet, to reach stable bedrock. The construction of these foundations is a feat of engineering, often involving underwater excavation and concrete pouring. With the foundations in place, the next step is to erect the bridge's superstructure, the part that spans the obstacle. This phase is crucial as it involves the assembly of the main structural elements that will carry the load and provide the necessary support for the bridge deck. The superstructure is essentially the backbone of the bridge, connecting the supports and ensuring stability. This is where the bridge's design truly takes shape. The intricate framework begins to emerge, showcasing the engineering marvel that will soon stand tall. Workers meticulously follow the blueprints, ensuring every component is precisely placed to meet the design specifications. There are various types of bridge superstructures, each with its own advantages and limitations. The choice of superstructure depends on factors such as the span length, load requirements, and environmental conditions. Engineers must carefully consider these factors to select the most suitable design for the project. Beam bridges, the simplest type, use horizontal beams supported by piers or abutments. These bridges are straightforward to construct and are often used for short spans. The beams must be strong enough to handle the load, and the piers must be placed at regular intervals to provide adequate support. Arch bridges, on the other hand, rely on the compressive force of an arch to distribute the load. The curved design allows the weight to be transferred along the arch to the supports at either end. This type of bridge is not only strong but also aesthetically pleasing, often becoming iconic landmarks. Suspension bridges, known for their elegance, use cables suspended from towers to support the deck. These bridges can span great distances and are ideal for locations where a wide, unobstructed passage is needed. The main cables are anchored at both ends of the bridge, and vertical suspender cables connect the main cables to the deck. Cable-stayed bridges are similar but use cables directly connected to the towers. This design provides a more direct transfer of loads from the deck to the towers, allowing for a more efficient and often more visually striking structure. The cables fan out from the towers, creating a distinctive pattern that is both functional and beautiful. Section 5. Paving the way, creating the road surface. This is where the bridge truly begins to take shape, transforming from a skeletal structure into a functional pathway. Once the superstructure is in place, it's time to create the bridge deck, the surface on which vehicles and pedestrians will travel. This phase is crucial as it forms the foundation for the road surface, ensuring durability and safety for all who use it. The deck is typically made of reinforced concrete slabs or steel plates, supported by a network of beams and girders. These materials are chosen for their strength and ability to withstand heavy loads and harsh weather conditions. The construction of the deck is a meticulous process, requiring precise alignment and leveling. Every measurement must be exact to ensure the deck is even and stable, preventing any future structural issues. Waterproofing membranes are installed to protect the deck from moisture damage. These membranes act as a barrier, preventing water from seeping into the concrete or steel, which could lead to corrosion and weakening of the structure over time. Finally, the road surface is paved with asphalt or concrete, providing a smooth and durable surface for vehicles. Markings are painted to guide traffic, and safety barriers are installed to protect drivers and pedestrians. This final step ensures that the bridge is not only functional, but also safe and ready for use by the public. The completion of the road surface marks the end of a long and complex construction process. It is a testament to the hard work and dedication of the construction team, who have transformed raw materials into a vital piece of infrastructure. Now, the bridge stands ready to serve its purpose, connecting communities and facilitating travel for years to come. Section 6. A bridge's anatomy. Key components and their functions. Understanding the anatomy of a bridge is essential for appreciating the complexity and engineering marvels that go into its construction. Let's break down the main parts of a bridge, each playing a vital role in ensuring the structure's stability and functionality. Foundations. These underground structures transfer the bridge's weight to the ground. They are crucial as they provide the necessary support to keep the bridge standing, even under heavy loads and adverse weather conditions. The foundation must be strong and stable to prevent any settlement or movement that could compromise the bridge's integrity. Piers and abutments. These vertical supports hold up the bridge span. Piers are typically placed at intervals along the bridge to support the spans between them, while abutments are located at the ends of the bridge, anchoring it to the ground. They must be designed to withstand not only the weight of the bridge, but also dynamic forces such as wind and traffic loads. Span, this is the part that bridges the obstacle, supported by the piers or towers. The span can vary in length and design, depending on the type of bridge and the distance it needs to cover. It is the most visible part of the bridge and often the most architecturally significant. Deck, the road surface that carries traffic. The deck must be designed to handle the weight and movement of vehicles and pedestrians, providing a safe and smooth surface for travel. It can be made from various materials, including concrete, steel, or wood, depending on the bridge's design and purpose. Bearings. These allow for movement and expansion of the bridge due to temperature changes. Bearings are essential for accommodating the natural expansion and contraction of the bridge materials, preventing damage and ensuring the bridge remains functional over time. They also help to distribute loads evenly across the structure. Each component plays a crucial role in the bridge's structural integrity and functionality. Together, they form a cohesive system that allows the bridge to perform its intended functions safely and efficiently. Understanding these components helps us appreciate the engineering expertise and meticulous planning required to build such impressive structures. Section 7. Iconic bridges, marvels of engineering. Throughout history, humans have constructed awe-inspiring bridges that stand as testaments to our engineering prowess. The Golden Gate Bridge. This Art Deco masterpiece connects San Francisco to Marin County, California. The Brooklyn Bridge, an iconic symbol of New York City, this bridge connects Manhattan and Brooklyn. The Millau Viaduct, this cable-stayed bridge in France, is the tallest bridge in the world. These bridges are not just transportation routes, but also architectural wonders that attract millions of visitors each year. Section 8. The final touches, safety checks and inauguration. As the bridge nears completion, rigorous safety checks and inspections are conducted. Engineers and inspectors scrutinize every detail, from the foundation to the paint job. Load tests are performed to ensure the bridge can handle the expected traffic volume and weight. Once the bridge is deemed safe and ready for use, a grand opening ceremony is usually held. This event marks the culmination of years of planning, design, and construction. It's a time to celebrate the hard work and dedication of everyone involved. Section 9. Keeping bridges strong, maintenance and preservation. Building a bridge is a massive investment, and maintaining it is crucial for its longevity and safety. Regular inspections are conducted to identify any signs of wear and tear, corrosion, or damage. Maintenance crews work tirelessly to repair cracks, repaint steel structures, and replace worn-out components. Investing in bridge maintenance is not just about aesthetics, it's about ensuring public safety. A well-maintained bridge can last for decades, if not centuries, providing safe passage for generations to come. Section 10. The future of bridges, innovation, and sustainability. The world of bridge engineering is constantly evolving. New materials, technologies, and designs are emerging, pushing the boundaries of what's possible. Self-healing concrete, for example, can repair minor cracks on its own, reducing maintenance costs and extending the bridge's lifespan. Sustainability is also a key focus in modern bridge design. Engineers are incorporating eco-friendly materials and construction techniques to minimize the environmental impact of bridge construction. Section 11. Bridges, a testament to human ingenuity. Bridges are more than just concrete, steel, and cables. They are symbols of human ingenuity, perseverance, and the relentless pursuit of progress. They connect us literally and metaphorically, reminding us that even the most daunting obstacles can be overcome. So the next time you cross a bridge, take a moment to appreciate the engineering marvel beneath your feet. It's a testament to the power of human collaboration, innovation, and the unwavering spirit that drives us to connect and explore.